Hello. Hi guys, good morning. Welcome back to a new video. In this problem, maximum strength of K disjoint subarrays. I'll give a big disclaimer. This video is gonna be long again. Next thing is you should have a pen and a copy with you. Please, the dry run which I'm gonna tell you or will do with you, please keep that with you so that you can compare what's happening. Because I have a small tablet, I cannot show you everything at once, but to visualize, you should be having everything at once, like I do it in my copy itself. Like you can have a simple visualization that we do. So that's the reason I'll highly recommend keep a copy and a pen, and then let's start off. So again, that's gonna be a hard problem. It's actually a hard problem. Max to max 190 submissions were there, and the problem description was also not good. But yeah, we'll see everything. It says that we are given a zero index which I call as nums, and the length is n, and a position, a positive odd integer. So okay, that's something odd. Maybe it is useful, maybe not, we don't know, but we will keep that in mind. It's odd integer, which is k. Now the strength of x subarrays. So we have the array nums which we saw earlier. Then we have another variable called as strength. That strength is defined as sum1 into x minus sum 2 into x minus 2. Aryan, what is this sum 1? So they have said sum I is the sum of elements in the ith subarray. So if I say sum 1, it will be in the first subarray, it is in the second subarray, and so on and so forth. I want that part. Okay, now for sure they have just made a general formula by that, but we know that we will be given k disjoint subarrays from nums. So as you saw here, we had x subarrays, so we will replace that x with the k, because we know that we have for sure, again, that is not saying at least k subarrays, at most k, no, it is select k subarrays. So we have to choose exactly k subarrays. Aryan, what if it is not possible? So you can see it is always possible. My k is less than equal to n, so for sure I can take one element and I will be able to for sure achieve k subarrays. So it's always possible. Now, and how we have to choose this k subarrays such that the strength is maximum, and then ultimately we have to return the maximum possible strength which can be obtained by choosing k subarrays. And there's just one thing lastly, they have said that it is not required to choose all the elements to build a subarray. What we mean by that is, let's say we have 5 elements and I have to make 2 subarrays, right? Let's say my case 2, I have to make 2 subarrays. So it's not important that okay, I choose all the elements while making my, again, that can be any combination. I can make like this as 2 subarrays, I can make like this as 2 subarrays, but it is not important to choose all the elements. You can also say that okay, this is one subarray, this is another subarray, or you can also say this is one subarray, this is another subarray. This is also completely fine. That is what the problem is saying. So again, your pain in the ass will become this point, and one point which is missing itself, that these subarrays needs to be in the order itself. What I mean by that is, now for sure by so far you must have seen that we can choose k subarrays. Let's say my k is 3. Now although the problem just simply mentioned that my sum 1 is nothing but the ith subarray sum. So that can be, by the question what it says, it can be any subarray, right? No, it cannot be, because if you take 1 2 3 minus 1 and minus 2, okay, you have k as 3, you have n as 5 elements. Then very obviously you can see also in the example they have taken the first subarray as this. Again, they have to take 3 subarrays. They have taken first as this, second as this, and third as this. This is what they have taken. Now if I change my input example by a little bit and shift this last subarray to the end, then by what the question is saying, then again the answer should have been same, which is 22. But it is not the case. Why the answer should have been same? Because for sure I can take this as the first subarray, this as the second, and this as the third, right? And then again still the answer should have been 22. But no, the answer is not this. It is less. Why? Because we have to take the sub-array in the order itself in which they are occurring, which means this should be the first, this should be second, and this should be third. Because taking in the order will always matter, because you will see that this is the first sub-array which is multiplied by x. The second sub-array is multiplied by x minus 1, which is the reduced value. Third is multiplied by x minus 2, which is again a reduced value. So ordering will matter, which they should have mentioned in the problem, but they have not mentioned it. That's the reason this question is being told a lot on Leetcode and stuff. Okay, so far we know that, okay, this should be ordered. That's one thing. But again, even if you would have known that it is ordered, still it's a hard problem. It's not that, okay, people would have done it. It's a hard problem. Now, coming on back, that now we know that my x is k actually. So my formula will look more or less like strength is equal to my sum1. Again, sum1 is nothing but first subarray multiplied by k. Sum2 multiplied by k minus 1. Sum3, again, remember, sum3 is I am taking 3 subarrays, and this is the third subarray sum. I am taking 3 subarrays. This is my third subarray sum. It is sum3 multiplied by k minus 2 and so on and so forth, and it will end with sum k plus 1. Aryan, how you are so sure it will end up with plus? Because see, sign will also matter here, because sign, again, I will say many things. Please make sure you take every point and will stick to that point. I repeat, there's a high chance there are many edge cases with this which you should make sure of. Now, Aryan, how are you so sure it will end with plus? Because bro, for sure they have mentioned my k is odd. If something is odd and we know it is starting with a positive, so okay, positive, negative, positive, negative, positive, negative, positive. Odd, which means this portion, negative, positive is even, add a plus 1, it's a odd. So for sure, if my k is odd, it will for sure end with a positive. And thus I can simply say it will end with a positive and will be a sum. Let's say I have k subarrays, so it will be the sum of the kth subarray multiplied by 1. So that's going to be my strength, and this is what I want to find ultimately. Now, we will not go on too much deep, because going on too deep and figuring out how you can solve it will actually, you will end up solving nothing. Break it down. Okay, break it down. Let's imagine that I have to find, okay, imagine I have only one. I have to find, okay, let's imagine I have only one subarray, and then I have to find this answer, because this is what this is what it says, right? I'll simply break it down. I'll go chunk by chunk. Let's imagine I have only one subarray and I have to find this value, maximum value, because remember, maqsad nahi bolna. Our aim was to get the maximum strength. It can only be possible when this portion is maximum, this portion is minimum, this portion is again, I am saying this portion is minimum. So if this negative is in absolute terms maximum, so negative will become positive, so it will become maximum. Like, don't go into this, we'll see it later on, but yeah, we just want things to get maximum. So now my aim, maqsad is that this one subarray should have maximum possible sum. Now, so we know that this is, we have taken the first one subarray and that's the sum of that first subarray. But Aryan, subarray, oh, I have a subarray and I want to just get one such subarray, just the maximum sum. An array of size n can have n square subarrays. An array of size n can have n square subarrays. For sure, bro. By the constraint itself, my n is 1e4. 1e8, you might end up thinking, 1e8 is less than 1e9, so it should work. By Leetcode constraints, 1e8 will not work. Again, by code forces, you can end up working, like you can make your 1e8 working also, but still, 1e8 for Leetcode will not work. Even if I would have said 1e8 might work, but bro, you have just only taken one portion. What about the others? What about the other? If you just end up taking everything, you will end up having a high complexity. So even if you might have okay, 1e8, it can work, bro, you have to go and check for everything. Like, you are just checking for one subarray. What about 2? What about 3? And so on and so forth. Bro, hold on. So you cannot do that. So now I got to know that, okay, I have n equal to 5. Like, my n is something. N square would not work. So something, I cannot go and find all these subarrays. I cannot go and find the sum of all these subarrays. But I know one thing. I wanted maximum strength. So ultimately, I want this subarray having the maximum sum. That's it. Yeah, that's it. So we know that, okay, my sum should be maximum. So again, Remember one thing, that you have to take just one subarray and that sum should be maximum. Now we'll come on back. Every time I have told you, just if you have some array and you have to find the question, the question should be crystal clear. You have to just take one subarray and its sum should be maximum possible, right? So again, we land on to simple one. Okay, there's balloons. Okay, we land on to just one index, any random index I'll land on to. Now if I ask you, if I am landing onto this specific index, bro, what should be the maximum subarray sum? Then you will ask, Aryan, what if it is not important? What if it is not important that, okay, my maximum subarray sum will not even include this? It might be here itself, it might be here itself, it might be here itself, it might be here itself. What if it doesn't include this? I'll say, bro, just do one thing. Imagine that you have to for sure include the specific element. Else, how would I know what all possibilities are there, right? So I will say, if I'm landing on this specific index, again, I'll go and do it for every index. So right now I'm saying, if I land onto this specific index, just tell me, if I'm landing onto this index itself, then ending at this index, what can be the maximum subarray sum? Now I'll do the exact same stuff. If I land onto here, so maximum subarray sum can be what? This or this or this or this. Aryan, how would I know? Bro, simple. Either, because see, you have to land onto here itself. Now it can be this or this or this or this. That's it. Aryan, no, it can also be this. It can also be this. You did not consider that. Bro, I consider that. How? Because if I will land on my pointer here, if I will say, because I told you, I will go on to every point, because it's just n points, 1e4 points, so I can go on to every point very easily. But if I go on to this specific point, so this will consider, and then this will be the next step for him. So that DE will be counted while I'm counting my E. So I can very safely count only the previous parts. So I can very easily say it can be a D, it can be a DC, it can be a, again, I have taken alphabets because it's much easier to represent something which is general, which is because we have negative elements, positive elements, all that stuff. I don't want to take in that. I don't want to go in deep in that. I just want to be alphabetical, problem solving. Cool. BCD and ABCD. So these can actually go for us. But still, Aryan, if you land onto the specific index, you cannot go on to all the previous MS1 indexes. You cannot do that. You cannot do that. Okay, that's completely fine. That's completely correct. What to do in that part? Just try to find answer, because see, you remember one thing. Maksad tha to get the maximum sum ending at D. So for sure ending at D, which means D should for sure be included. Oh, I can simply go and ask my neighbor, bro, can you please tell me what is the maximum sum ending at U? I'll go and simply ask my neighbor. Okay, I'll go and ask my C. But Aryan, how would I know that I have to go and ask my C? I got to know one thing, that okay, you will for sure include D. You will for sure include D in your answer while computing the maximum sum ending at D. You will for sure include D. But how would I know that I will have to go and ask my C for maximum sum? Because bro, this is how you would know, is because as I showed you, these are the possible cases. Right? I will break these cases down. Let's break this specific case, DC. You will see D and then C. When C would have been computed, C would have told, bro, maximum sum ending at me can be this, right? And same way, it can be BC. So BC and then D. You will see BC and then D. Again, same way, ABC and then D. ABC and then D. Did you catch something? It is exactly same way saying, bro, I don't know what you are doing. I just wanted maximum sum ending at D. So I'll say, bro, no worries at all. You can just go and ask maximum sum ending at C. Maximum sum ending at C. Your C will give what was the maximum sum ending at C, which means it will give maximum sum from here or here or here. Then I can simply add a D in that. That is how I can simply do or ask my C. So basically, C needs to store that maximum sum, and I will take the help from that stored value from C to compute my, which is the D's maximum sum. So what I did was, I was simply at my D I simply went on and asked, okay, bro, again, storing something, memoizing something, we can simply refer as a DP. Again, I'll dry run this also for you, but I'm just telling you in a contest how you can think of, in an interview how you can think of. You cannot end up dry running everything in an interview, but still, for your understanding, I'll dry run after this. So what we have figured out is, okay, if we are at D, we will for sure add nums of I into K. Again, the contribution of an element to its sum is what? Remember that, bhulna nahi hai, it's the reason I told you. It is sum, which is the element sum multiplied by K. So, which means the contribution of D will be nums of I, which is here in this case D, multiplied by K. And okay, adding that with whatsoever I have got the maximum up till so far, which is dp of I minus 1. It is I minus 1. But Aryan, by this case, okay, this is one case, this is number 2 case, this is number 3 case. But in this, you showed us 4 cases. Yeah, that is true. So here you will see, okay, C is included, C is included. So these 3 cases I showed you below. One case will come extra, which is only D is there, right? So I'll say, okay, bro, one case can be, okay, I have only D. So contribution will be nums of I into K. So again, I want maksad nahi bol, I wanted maximum. I wanted maximum sum. So ending at ith index. So it will be either this value, which is the sum, which included previous thing also, or this value, which is including nothing but only D, ending at nums of I. So dp of I will be maximum of this value or this value. So I can simply say my dp of I will become maximum of dp of I minus 1 in plus nums of I into K, or nums of I into K only. Now, let's see for the folks who want dry run. So what happened in the very beginning? Again, our aim was to get ending at I. What could have been the maximum sum ending at I? Sum we remember how we find the sum. So very basically, we can start off from only A. Now, if we have only A, so which means, okay, let's imagine this as index 0. So we have dp of 0, which is for sure we can say it is A into K, right? Nums of I into K. Nothing else. I cannot. I have to take just one subarray. Again, remember, I am taking only one subarray. Remember that fact. It's the reason I told you in the very beginning. I am taking only one subarray, and then I am just deep diving into that one subarray only. Okay, what if I am at this specific I? I want again ending at this index I. What is the maximum sum? So I know I minus 1. It is stored here. Here I equal to 1. So either I can take only B, or I can take both A and B. So what I can simply say, either my dp of 1, it can be nothing but my dp of I minus 1, which is this value, plus B into K, which is dp of I minus 1 is this value right here, plus B into K is this. So I'm taking both of them. Or I take only B, which is simple B into K, which is this value only. I ignored this. So with this fact, you can easily see I'll get the maximum. What is dp of 1, which means ending at index 1. What is the maximum sum I can get? So it can be either I have only B, or I have both A and B. Now the same way, expand it, expanding as in, okay, add a simple C. So either my C can be individual, that's one case, or C can club with B, or C can club with AB. So I'll simply say my C can club with B, my C can club with AB. And then, okay, one case is my C is individual, right? And these two cases, I can simply go and ask, bro, what is the maximum sum up till this index I can achieve? I'll simply add a C into K. Or one case, I'll simply have a C into K. Maybe that's the maximum sum. Who knows? And then at this point, I'll simply try clubbing my D. So I can club either a D with C, or a D with BC, or a D with ABC. So I'll club my D with C, I'll club my D with BC, I'll club my D with ABC, or I can have my D individual. And that's how, by just only referring your previous maximum sum, you can achieve in O of n time. What is the maximum sum? Taking only one subarray, ending at these corresponding indexes. Okay, Aryan, what is the use of that? I have to find my strength. Okay, Aryan, you have done this. Okay, it will take O of n time. then will you go and do this? Maybe yes. Because if you see very closely, this took O of n time and we have found this. Now, we know that we have k. We know that, okay, it is k minus 1, k minus 2 up till 1. So we know that, okay, these are k elements. So Aryan, by the fact which you are going and trying stuff, you did this in O of n time for just one subarray. You did it O of n time. What if you are able to achieve everything in O of n time, O of n time, O of n time? Then it will be in total O of n into k time. Will this work, Aryan? Let's see. O of n. N is 1e4. Okay. K is also 1e4. 1e4 into 1e4. N into k will not work. N into k will work because n into k, they have put a constraint. It is less than 1e6. So n into k will work for us because it is actually 1e6. It is not 1e8. It is 1e6. So we know one thing for sure, that we are going in the good direction. We can we may be able to achieve it. But the trick will start because now we have two subarrays. Earlier we had only one subarray. Now we have two subarrays. Let's see that how we gonna solve this. Okay, now coming on back. Okay, where have I gone? Two subarrays. Now, okay, so now the next step, this we have done. One subarray is done and we can easily able to achieve it. Now we have two subarrays. How we will solve it? Again, we will not go much. We'll simply have a very high level overview of what things what things are required. First thing is that we should be very much aware about the sign. Sign is very important thing. Although here we just did element into k, all that stuff. Good. But bro, sign is very much required. And for sure, you remembered one thing. Your k was odd. They have mentioned your k was odd. Again, everything will matter. Your k was odd. Let's say your k is number 7. So here your k will be 7. Here your k will be 6. Here your k will be iron. Again, when I say k, I mean current k, which is the value k minus 1. This is the current k value, which means at the current point, what is the k? Resultant k you have. That is nothing but 6. That's 5. And so on and so forth. So you will see, wherever your current k value is actually even, the sign is minus. So I can simply say that I want few concepts to be clear, that if my current k value, again, I want the current k value, which is nothing but k minus at which step I am. If I am at the first step, see, this was the 0th step. This was the first step, step 2, and so on and so forth. So if I am at, I can simply go and find my current k, which is nothing but k minus j. J is nothing but I am at the jth step. Right now, if I am taking for two subarrays, I am at the first step. 0th step is already done. In CS, we have zeros. Cool. Now, so if my current k is actually even, then my sign will be negative, else my sign will be positive. Okay, my sign is sorted and my current k is also sorted. Right now, I am at the first step, so it is k minus 1. Okay, my current k is sorted, which means my this value is sorted, my this sign is sorted. Now let's come and find for the second subarray what should be the sum. But Aryan, it is saying for the second subarray, but here you have written that you have two subarrays. That's the trick, that I will use whatsoever answer I have found for one subarray, and then maybe I can add something to get for the second subarray, so that I can get to know if I take two subarrays, what should be the maximum value. So imagine you have to find the strength and you have just two subarrays. You just have two subarrays. So let's go and tell what should be the answer. Again, we will take a random index ending at d itself. Always take a random index to find general formulas, right? And again, if you are very much in how to take random index and stuff, go back and then try to do a bottom-up approach. Now, okay, we'll take a random index. So we are at here. Then we want two subarrays. That's the first question. So Aryan, are you saying we want two subarrays? Earlier, while I was finding my answer for my one subarray, I took one help. What was the help I took? Okay, I was at the ith index, so I asked again. I'll take the help from the previous concept which I have already known or studied or gathered the information from. So While I was computing answer for my one subarray, if I am at I went on and asked my I minus 1 only to know and to get the maximum subarray sum ending at that I minus 1 index. Right? Because I know, and because of that reason, I was only doing a O of n time because to iterate on all the elements. So I never went on previously for anything else. But now I am saying I have two subarrays. So I can easily, you can easily counter example and say to me, okay, Aryan, what I can do is I'll take one subarray here and the other subarray, it can maybe end here. It can maybe end here. So are you saying that, okay, earlier your I was here and I minus 1 was just previous. Earlier was like this. Earlier was like this, kind of like this. But now you have to take two subarrays. You have to take two subarrays. So are you saying that for the previous subarray, and again, you want maximum subarray ending at that specific index, which is I minus 1 here. So are you saying that you will go and land on this specific index? You will go and try for this index ending at here, then this index ending at here, then this index ending at here? I'll say no. My statement is both the subarrays, again, you know that you have to take two subarrays. You know that fact. But my statement is both the subarrays which you are taking, either it can be this, again, remember the fact you are taking now two subarrays. So both these subarrays, which means this is the first subarray, this is the second subarray. It can be in any combination. It can be that this or this. It can be this or this. It can be anything. But it cannot be this or this. The two subarrays cannot be like this. But Aryan, you are lying. In the very beginning, you told that it is not important. In the very beginning, you told that the selected subarrays, they do not need to cover the entire array. So you never need to cover the entire array. And I'm also saying the same thing. They do not need to cover the entire array, which means the two subarrays can be like this. But Aryan, what's the difference? My saying is that both the subarrays will actually be adjacent to each other. But Aryan, why? How can you say that? Like, what's the point in that? The point is that if you are taking two subarrays, right? Let's imagine what you have taken. Okay, let's imagine that you have taken this as one of the arrays and this as another subarray. By my example, I am saying these both needs to be adjacent to each other. But you can see here you have one element in between. Now you might say, Aryan, this is giving maximum answer. But I'll simply counterly ask you, bro, if you are getting a maximum answer from this, which obviously mean that a plus b multiplied by k and then minus d into k minus 1. This is your result. This is your result. Considering you can take any signs whatsoever which can give you maximum value. And for sure, to get the maximum value, you must have taken a and b both as positive and d as negative. In the best case possible, let's think of. But now I'm saying, if this c, again, the c can either be positive or negative or 0. Right? Consider the positive and 0 are, let's say, same. Now, it can be either positive or negative. If my c would have been positive, so I would have clubbed it with my k, and then it would have, why the balloons go away? Cool. Then I would have clubbed it with k so as to make it as a bigger value, because I want my strength to be maximum. So if my c would have been positive, I would have clubbed it with my ab. If my c would have been negative, I would have clubbed it with my d. So that's the reason, to get the maximum score, I will always be having both of them as adjacent to each other. Both the groups, both the subarrays will be adjacent to each other. So with this, and again, that's a very big observation, with this, you would only be wanting to ask your previous index for anything, whatsoever you want. Aryan, how you will do it? I'm still confused, because it's still two subarrays, because what if this specific subarray is this, then the previous subarray is this, then will you go and ask this index? I'll not. You will see that part. But yeah, the point is that both these subarrays will be adjacent, which means that, again, taking the same example of only two subarrays, and imagine that some initial elements are negative, then a few elements are positive, then a few elements are negative, and then a few elements are positive. You remembered you have to take two subarrays, and you remembered the first sign is positive, so you will take the positive one, and then for the second subarray you will take the negative elements. So the question was saying that it is not important that you take all the elements. So I ignored these elements in the beginning which are negative, I ignored these elements which are positive in the end, and then by that reason I don't need to take all the elements of the array. But the point is that both these subarray will be adjacent to each other. Now that's the biggest point which will help you a lot in future. Coming on back, now my main aim was ending at this index. I want to have two subarrays. Again, remember the fact one thing, I will take both of these subarrays with a different color. So let's change the color and put it a green. So green is my right now pointer, and these are already made notes for you. So you will see that what possible cases you can have for two subarrays. One possible case is my D is only one array and my C is only one array, but you will see both are adjacent. Adjacent will help us a lot. Make sure that part. Now D is 1, okay, BC is 1, okay, D is 1, ABC is 1. But Aryan, still they can be multiple variations. Yeah, they can be that. Okay, what if your CD is 1, Aryan, where's the other one? Okay, other one I have put it here. What if your CD is 1 and other one is B? What if your CD is one array, other one is AB array? What if your BCD is one array and A is other array? What if your ABCD is one array and the other array cannot be empty? It needs to be an array. So this will not make two subarrays. Remember the fact I am right now doing for two subarrays. So I need to make two subarrays. So I got to know that these are all the possible cases. This, and these three. Now let's deep dive into from the very beginning. How I again, मकसद नहीं बोला. Our main aim was ending at this specific index. Ending at this index. I know I need to have two subarrays. Ending at this index, I need to know I have two subarrays, and then our balloons. I need to know I have two subarrays, and then what's the maximum sum, right? Cool. Now I'll go on from the very again. I have pointed it. It's 1, which means when your D was only D, when you're at the index 3, it was only D. Then variation 2 is when you had from D you have something more, and then when you had only when you had DC, when you had only DC, then the other variation is all these two variations. When you had a BCD as the second subarray, then you have this third variation. So let's backtrack and see what happened and how I can find my answer, which is maximum subarray sum ending at that index, considering I have two subarrays. Now I went on from the very beginning. Okay, 3. Now in the variation 3 which I saw, again variation 3 is, that's the reason I told you take the notes of everything. So this variation 3, variation 2 has these two variations. Variation 3 has only one variation, and variation 1 has 3 variations. Cool. Now variation 3 we are at. Now we found out, okay, this is the second subarray, this is the first subarray. Now Aryan, by your point, I need to know this answer. For me, this answer is nothing but A into K minus B plus C plus D into K minus 1. So Aryan, are you saying that I need to have a prefix sum? Because see, one point you can easily say, okay, Aryan, I can see I need to have a prefix sum, and then I'll try for the prefix sum itself, and then maybe I can find the answer. And for this, I can simply take my DP of J or something of that sort, which will give me a maximum sum ending at that index with what? With one subarray. Remember the fact, now you are dealing with two subarrays. So you will go and ask him for one subarray. But I'll say, bro, hold on. We can do this maybe, but let's start from the very basics. Bottom up. We will see everything, how things are being built. So we were randomly starting at the index D. But let's backtrack and see what happened. What if your again, blue is one array, A is other. White one is one subarray, blue one is another subarray. So if you add the specific index I can simply say, bro, I want to know the maximum subarray sum ending at I, considering I have two subarrays. I know that they both are adjacent. They both are, oh, bhai, please stop these balloons. I know both of them are adjacent to each other. So I know I minus 1 will be my previous subarray. So I can simply go and ask, bro, I am at ith index. Now I am saying I have, this is my second subarray, or I can say this is my first subarray. 0th subarray is done. Remember, in the beginning I told you it's 0 based indexing. So let's say 0th subarray is done. I am in right now, because remember, I am right now finding my answer for 2 subarrays. Where is this gone? I am right now finding my answer for 2 subarrays. So I have to distinguish my DP values, because if you remembered, DP values I have already found out. If you go and see up, DP I have already found out. But this DP which I have found out earlier was for just one subarray. So I can easily say this DP value is DP of I comma 0, which means I have considered only one subarray. DP of I and 0. I have considered only one subarray. I now need to go and find for 2 subarrays. So I'll simply say right now my values are DP of I and 1. 1 is for, okay, I now need or want for my second subarray. What it can be? It can be simply going on to I minus 1. Simply going on to I minus 1. Because it's your neighbor. You can see it's your neighbor, but it is saying, bro, I am I minus 1. That's good. But I was build saying that it is the first subarray. So it was, again, let's name it as a 0th subarray. So you went on to your back, but you saw it is I minus 1, that's correct, but it is the 0th subarray answer which you wanted. So this will give you the maximum sum ending at I minus 1, considering it was just previous subarray, because you are not right now in a new subarray. Okay, bro, this will give me a into k very easily. You can see also. And right now I have to add what? I have to add a b. I have to add a current k. Again, if you remember, current k we have already found out. Current k we have, and we also have the sign. What sign we should have? What sign we should have? Either it will be plus 1 or minus 1. So I can simply say now my answer will be b into current k multiplied by sign. So you can easily see the right now my strength value will be a into k, which is for the first subarray, and for the second subarray it will be minus b into k minus 1, which is this specific part. For the, again, I wanted the maximum sum, so I simply went on and asked my brother, which is at I minus 1 index. I asked my brother, bro, can you please give me the maximum sum ending at u, but considering, okay, you are a 1 subarray, you are the first subarray. Aryan, what if, because if you remembered, I am going on incrementally. Okay, I took a b because it can be still, again, make sure, maksad kya tha apna? We have to make a third variation, which was BCD, all of second subarray. So now B is done. I'll now go on to my C. Now my C is again of the second subarray. So here's my I. I'll again go and ask him, bro, and again, I know I have to do every operation in O of n time. So I can only go and ask my previous neighbor, which is I minus 1. So I'll go and ask him, bro, I am at DP of I, and that's I am at a second subarray, which is 1. I'll go and ask you, which is DP of I minus 1. But I know you are also the part of the second subarray. So I'll go and ask 1 only. That's a difference. You are not going and asking a 0. You're going and asking a 1. Aryan, what if I go and ask a 0? We will see that part. We will have it a minimum value. We will allot or assign it a minimum value, so that if you go and ask, you'll get a minimum value, and you want the maximum answer. So that will be already done. And then when this is done, you will simply say, okay, C multiplied by current K multiplied by sign. That's the addition. What happened with that? You see, the thing which you have found already earlier. See, this is the thing which you have found already earlier. That was A into K minus B into K minus 1. A into K minus B into K minus 1. You just simply added this, which is a sign minus multiplied by C into K minus 1. We saw what happened with this. It is A into K minus B plus C into K minus 1, which is A into K minus B plus C, which is the subarray sum of the second subarray into K minus 1. Okay, simply go on. Remember, maksad nahi bhulna hai. Our maksad was to get to this BCD in the second subarray. So again, D, if I am at I, I'll simply go and ask my previous index, which is I minus 1. If I go and ask him, he will simply say, okay, bro, dp of I comma 1, dp of I simply say, okay, dp of I is the maximum subarray sum ending at this index. Considering it is the second subarray, I'll go and ask my previous index, which is also a second subarray, and then I'll simply add the current contribution, because I am saying I will end at me. It will for sure end at D. So contribution will for sure be added. Now this will simply say, you can see it will simply become a into k minus b plus c plus d multiplied by k minus 1. Okay. Now with this fact, you can simply see that, okay, in O of n operation, you have simply found out what can be, okay, at this specific index, what can be the maximum subarray sum if I say this is my contribution with my second subarray. But Aryan, you only did right now for this specific BCD. Then next time what you will do is you will go and do it for the next variation, which is the variation 2 and then variation 1. So for one variation only you take O of n time. Isn't it bad? I'll say no, because while finding the answer for this variation, what I did was I actually did something for others also. What I did, or maybe I can say others did something and I used it. That my B and A, this variation, I found out. A and BC, this variation, I found out. A and BCD, this is what I had to find out. So I can simply say, to find out the answer for my current variation was B, C, D and A, I simply went on, I was at the ith index, I went on and asked my I minus 1 index, and I simply said, bro, dp of I know I am at the second subarray, it will be nothing but my dp of I minus 1. I found out either my I minus 1 can be a first subarray or my dp of I minus 1 can be my second subarray. But whosoever is maximum, I want that part. But no matter what, I want to end at this specific ith index. So I have to add its contribution, which is nums of I multiplied by current k. That k I can easily find, multiplied by sign. That sign is very important. So this is nothing but your dp of I for the second subarray. And you will see the exact same stuff I have written exactly right here. Okay. Aryan, that seems so good. We are maybe, okay, I know, yeah, you have got the answer, but let's, for your safety or for your concern, let's also dry run variation 2. Again, if you remember, variation 2 was saying we will say, okay, DC is one variation, which means DC is the second subarray. First subarray can be either a B or can be either a AB. Now, my point is, I'm simply saying, okay, I am at I. I'm simply saying, I'm for sure saying that I will be having an answer from I minus 1. I will be having an answer from I minus 1 for sure. For sure, I will be having an answer from I minus 1. How? You can simply see that if we again go and backtrack, if I am at the specific I, again, I am simply going and trying to say that I am trying to build this specific value, right? Where I have B as one subarray, which is the first subarray, and CD as the second subarray. So if B is my first subarray, C is my second subarray. Ending at C, I can simply say dp of I ending at ith index for the second subarray, dp of I minus 1 for the first subarray, and then contribution of C. Again, exact same stuff, but you remembered my main aim was D also should be there. So when I will go and find the answer for D, I'll again go and ask only my back one, which is I minus 1, because I want to get everything in the least time. I cannot afford more time. I have to get done everything in O of n into k. That's it. So I am at the ith index, which is the second subarray. I'll go and ask my previous index. Either it can be my first subarray, or it can be, again, this can be my first subarray, or it can be my second subarray. Both will work. Whosoever will give me maximum, again, you will see this addition is nothing but nums of I into current k multiplied by sine. Nums of I into current k multiplied by sine. Whosoever is giving me maximum result, I'll take that. That's it. For me, I am greedy. Whosoever is giving maximum, I'll take that. So I'll simply say this I have already found earlier, which is b into k minus c into k minus 1, b into k minus c into k minus 1, and then minus this current thing, it will become a b into k minus c plus d into k minus 1. So you will see b into k minus c plus d into k minus 1. That is my answer for taking, okay, 2 subarrays. And the same way I can say for this variation right here, again the exact same stuff I'll repeat, that ending at the ith index for the second subarray, ending at, you will simply go and ask your previous index and then say and ask him, considering he is my first subarray and then the current contribution, ending at this index, I go and ask I minus 1, considering, okay, previous index, and then why it is a 1 here, okay, again sorry, it's a 1 here, cool. At the ith index, it is the second subarray, I minus 1 index, again second subarray, and then contribution of the current index. That's going to be my answer. So you simply have realized one fact, that your dp of I for the second subarray, it will be maximum of dp of I minus 1. Either it can be a first subarray, which is just the previous subarray, or dp of I minus 1 with the current, which means the second subarray. Whosoever is maximum, giving me maximum, multiply plus the contribution of the current index, which is nums of I into current k multiplied by sine. Now, if you want to generalize that, you can simply say that, okay, how many subarrays I wanted? Okay, this was the second subarray. How many subarrays I wanted? I wanted k subarrays. So I can simply generalize this by saying dp of I k will be nothing but maximum of dp of I minus 1 k minus 1 dp of I minus 1 k, whosoever is maximum. Again, if you want to take maximum, we have to by default initialize that with the most minimum value. We'll see what's the most minimum value, but still we have to initialize IDP with the most minimum value, plus your nums of I, okay, let's have a good handwriting, plus nums of I multiplied by current k multiplied by sine. Cool. That's gonna be your actual DP state, but you have to build everything. So how your state will go about, because you saw here it is 1, in the beginning it was 0, so from 0 1 up till it will go to up till k. The same way we go from, like, for our I, so we know our I actually will go in from 0 to n, our j will actually go in from 0 to k, right? And that's how we can simply find our answer. And again, we simply know what's the current k. We simply know when our j was 1, our current k was k minus 1. So I can simply say my current k is k minus j. And I also, if my current k is even, then my sign is negative, else my sign is positive. Cool. So I can simply know my sign, my current k, my nums of I for sure know, and this is the formula which I have derived. Great. Let's see how we can actually simply visualize that again, because you can simply see it's a 2D DP. So let's have a quick visualization of how and what we have done. In the very beginning, you saw I found out the answer considering I have only one subarray, which means I was taking my j as 0, and I went on and find the answer considering I have only one subarray, right? So I'll simply go and I'm just showing you how you can actually visualize in your mind. I'll not draw the entire DP diagram, all that stuff. That's bullshit. I'll simply show you how you can actually visualize that. What has happened so far. So in the very beginning, you saw that you went on and find the answer for one subarray, which is your j is 0. So it's the reason if we just draw the DP diagram, we will simply have because okay, our state is I and j, where I is from 0 to n and j is from 0 to k. So I is from 0 to n, j is from 0 to k. Remember the fact, j0s represent one subarray, j1 represent I have two subarrays, and so on and so forth. What we have already seen in the very beginning, the first step, when I'm taking only one subarray, I went on and find this specific answer. Right? When I was taking two subarrays, I was again, you simply remember the formula, which is dp of I comma j. You saw it is dp of I minus 1 comma j minus 1, dp of I minus 1 comma j, and plus nums of I multiplied by current k into sine. So you, to find out this green answer, you went on and asked for your this pink answer, which is dp of I minus 1 comma j minus 1, and then you went on and asked for your dp of I minus 1 comma j, which is saying, okay, last index, which is I minus 1th index, considering the previous subarray, I minus 1th index considering the current subarray, and thus you need these values. One is the diagonal left, one is the top one. So you are actually computing, okay, firstly you saw that, okay, you have to compute this part, then you know you have to compute this part next, then this part next. So when you are going on to all the j's, okay, you are going on to first j, then next j, then next j. As you are on to any j, you have to compute the answer for all the i's, because j says one subarray. This j equal to 0 says one subarray, then 2, then 3, and so on and so forth. So for one subarray, find the answer. For 2, find all the answers. For 3, find all the answers. So your loop will for sure look like, you will have your j loop. Inside that j loop, you will have your I loop. J loop will say number of subarrays. I loop will say for all these elements. So that's how you can simply see that how your loop needs to work in, and for sure the condition is exactly the same condition which we have here. Now let's see the code. It's pretty simple. Again, one thing from in the very beginning, I told you that you will have to ask your these two values. So considering whosoever is here needs to be like returned. Whosoever is here. Now when I say whosoever is here, I for sure mean that maybe this is here but this is not here. This is here but this is not here. So I don't want to get into, okay, who is there, who's not there. Simply by default initialize with the most minimum value of your dp. Now what can be your most, again, if you remember, this dp is nothing but the strength. This dp is nothing but, remember the state. This dp of ij is saying, considering I am at the ith, I am ending at the ith index, I am taking j subarrays. Again, by default you can say I am taking j plus 1 subarrays. This is, I am taking j plus 1 subarrays. What is the maximum strength? So it is saying it's a maximum strength. So by default initialize with the minimum strength. Now what can be the minimum strength? If you had gone and seen, the strength is summation of sum multiplied by k minus next sum of the second subarray multiplied by k minus 1, and so on and so forth. Now if I take the very possible worst case, let's imagine that all these are k's, not even k minus 1. Let's imagine all these are k's, and here again remember, I want the minimum strength possible. Let's imagine my this sum 1 is negative. It is negative. It is, let's say, positive. Why I'm keep positive? So that it becomes negative, because I want minimum strength. And again this I'll keep as negative, and so on and so forth. So you can see, if example I'll take, if I have 5 elements in my array and my k is also 5, and if I have to build my answer, so for sure first element is negative, I have to take it. Next positive, I have to take it. So this positive will go here, and this will become a minus positive into k. Again, k is a bigger value. It was a k minus 1, but I'm just telling you what can be the very higher upper limit. Cool. Now, and so on and so forth. So you can easily see that the worst or the minimum possible answer, again, the answer will be not that minimum, because you saw I actually increased it to k. It was actually k minus 1, but still minimum answer can be minus 1e9 n times, because minus 1e9 n times can be there. This again, Rn, it is k times. You can also say, but your k limit is actually bounded by n, so you can say it is n times, or you can say also k times. Both are fine. So minus 1 into k or minus 1 into n, that gonna be your answer. Minus 1e9 into 1e4 minus 1e13 is the minimum strength which you can actually achieve. That's the minimum strength. So by default, I can initialize my minimum strength as minus 1e13, and my also I can say minimum strength is minus 1e13, because I want the maximum strength. So okay, just simply maximize this value. Now coming on back, I'll do exact same stuff which I told you in the very beginning. I found the answer for one subarray. I found the answer for one subarray. So I'll simply go and ask and tell my bro, at the index 0, considering I have only one subarray. Remember the fact, okay यार तुम भूल जाते हो. Remember the fact, what was the array? Array was 1, 2, -1. Okay, 1, 2, 3, -1 and 2. At the 0th index, remember the fact, I was going in from left to right, so I cannot look into right. At the 0th index, considering this is the index itself, I have to take only one subarray. What is the maximum strength? I'll say bro, maximum strength is 1 into k, nums of I into k. That's maximum strength. And then for one subarray, go and find the answer. Okay, at the ith index for one subarray, what is the maximum answer? So you saw, I did one thing. I simply did one thing. I was at this index I went on and asked what's the maximum ending at this index. So I minus 1. Again, it's just one subarray, and then I minus 1 ending at this I minus 1 having only one subarray, adding my nums of I into k, which is the current element. Or maybe I don't even take this previous thing, then okay, nums of I into k. That's going to be my answer. Okay, that is, I am taking only one subarray. Okay, that is built. Now simply build in, go in from your j equal to 1 to j is less than k, which is saying, okay, it is the 2 subarrays, then 3, then 4, then 5, and so on and so forth up till k subarrays. You will simply go on. Then you will simply go and find your current j, sorry, your current k, which is, as we told, it is k minus j, and your current sign, which is nothing but, if the current k is even, then the sign is negative. If the current k is odd, the sign is positive. Now, when we have got or done this, we'll go on to all the indexes, and I'll simply go and simply say that again, exact same formula, that okay, nums of I into current k multiplied by sign plus maximum of either I minus 1, I minus 1 into j minus, like I minus 1 j minus 1, or I minus 1 j. Exact same what we saw in the formula also. And that I'll simply assign it to my dp of I comma j. In the very end, you saw that you have to find the maximum strength for k subarrays, and it can end at any index. So I know it can end at any index, but I want for k subarrays. My indexing was k minus 1. So I'll go and try for all of my indexes. Because it can end at any subarray, it can end at any index. I just want my k subarrays, and that's going to be your maximum strength. And simply return that maximum strength. That's going to be your answer. Now, your time, as you can simply see, it is k into n. So your time is nothing but O of n into k. And you saw by the constraints, your O of n into k is 1/6. And the same way, your space is also O of n into k, and that's also 1/6. And that's how you can simply solve it. That's going to be a 57-minute video. Cool. Thanks for watching. Again, if you had followed by making notes, you can simply correct everything together. If not, then you'll get a very hard time understanding this, because it's a actually hard question. Cool. Bye bye. Thank you. Cool. Bye. Cheers.